Welcome back. We're going to be looking at partials today, and this is something that's quite related to closures and very expressive for doing lots of interesting things. So let's take a look at what this is. Right. So this is all about partial evaluation. And this happens when you have a function that has multiple arguments, but you'd like to specialize it by saying, oh, well, I mean, actually, not all these arguments are useful to me. In my case, some of these arguments are fixed to maybe a constant value, and I'd like to have an alternative function that has this constant value hard-coded into this. How can I do that? Is this doable? You can actually clearly do this in functional languages, but C++ is certainly not lagging behind in that respect. And it can be done with a brand new concept. So that's a C++ concept, is the std bind template function. So let's take a look at what this is all about. Remember our fine example from last time? Again, it's the unfixed version. That's the one that takes two doubles, right? I would much prefer that the function take two t's, but fundamentally, that's my find implementation that's making use of compare, and I'm passing as a first argument the value at the midpoint of the array and the value I'm looking for, right? And I'm assuming that my array is sorted. That's still the same story as always. So yes, that's great, but how am I actually making use of that variable v here? V is what I'm looking for. Let's see how v is used. Line 1, well, no v. Line 2, no v. Line 3, no v is computing index. Line 4, when we use compare, we use v. And then the rest, no v whatsoever. So the only place where we use v, where we read from it, is when we call compare. At the same time, we never write to v. So v is never written to, and v is read to only within this call, which is compare, which is another argument. So why on earth do I need to separately pass the value I'm looking for and the comparator? Couldn't the comparator simply return a value on whether what we're looking for is smaller than, greater than, or equal to the value we're looking up in the middle of the array? That is, could we embed v directly inside the comparator and eliminate one extra argument? V would be gone. And then we would have a function here that takes only one argument, xmid, the value that we wish to compare against whatever it is that compare compares against. So that's the whole idea. I want to be able to do that because it would simplify my API. Rather than having a function with 3 arguments, I would be back down to a function of only 2. That's a little cleaner from my point of view. And there is no reason not to actually explore that. So of course, this happens in lots of other contexts. This is just an example to actually put us through the pace of the exercise. So this is what I want. I want to have an std function that returns an int and takes a double. That's my compare. And here, when I call compare, v is gone. I'm just using compare passing in xmid. So what I clearly have at this point is compare is that beautiful little cloud, and now it only takes a value y. Typically, it's going to be x at the midpoint. And that is being fed inside compare, and out of this comes either -1, 0, or +1, depending on whether the value I feed is equal to a v, right? It's like there is a little hole in that function, and I want to bind v to it, in which case there is no point for find to take v anymore. The second argument is gone. I want to do that rather than what we've seen before, which is a little cloud compare that used to take 2 values, v and y, and output it a single thing, right? So I want to go from this form to that form and do that relatively automatically. And that's what bind is all about. That's what it provides for us. So we see what find would look like, right? Find is not the difficulty. The point is, if I have this compare already defined, can I manufacture this one without writing it again from scratch? I don't want to hard code this. I want to reuse that and embed it in here. That is, the picture I'm looking for is the following. Now, let's do this. I want to basically take that. I'm going to clean up just a little bit. Take that guy out. to get some space, I want to take that guy and basically say, oh, what I want to do is build that. That's the function I want. And what will happen is that the y will come right through over there. Then the v is in a little bubble that's embedded in the function, I don't care. And whatever the output was is the output that comes out of the pink function. But that's all I want to do. I build the pink one out of the one I already had. And I want to capture that v. Okay? So that's the whole idea. So yes, it can be done. And here is the example. You see the usage here. And we're going to look at the code in a second in real life. I'm going to make use of std bind. And I'm saying, yeah, I'm going to build that box by actually taking the compare, this one that we had, the compare that's inside, right? Here it is, the compare that takes two double, captures an epsilon as well for good measure. So I take that compare, and I'm going to bind the arguments in the following way. _1, that is, whatever used to be the first argument of this guy, in this case the y, is going to be a pass-through. That is, the argument that goes in, I also take it in. So that's argument _1. So that's _1. That guy is passed through. And then the second argument, the v, is 1.666. I'm hard coding it. Now, once you've bound, you've created the pink box, which is another closure, with this thing embedded inside, one argument passed through my output, and I pass it to the find we just defined. That's it. That's all there is to it. By doing that, I avoid the trouble of redefining another closure from scratch. I can use the one I had and build another one around it that achieves exactly what I want. So that's very flexible, and that's the only change in the program to make it work. So that's a very effective way to do. So bind works in a number of concepts. It works with C functions. It works with C++ method, and obviously you've just seen it. It works really well with closures. And we're going to look at examples of this multiple times. We'll keep coming back to it. What are the semantics of binding? Well, it's quite straightforward. We can see that bind does a few things. First, it defines a brand new closure, the pink one, right? Based on the green one, the source. So new closure automatically. Some arguments are passed through. That's what we call the placeholders. So this guy is a placeholder. It's telling me it's a pass-through. So I'm specifying which arguments come from the outside and get funneled directly into the closure that's embedded into the result. Others are captured, and they're given a value right now. That's the case of v. This argument, I gave the value I wanted to associate to it. So that's all there is, really. New closure with some placeholders for the pass-through and some being bound to a specific value. The difficulty, again, shows up because in C++ we have destructive assignments, and therefore we must be able to distinguish passing by value versus passing by reference. That's something that's fundamentally different. By the way, you can read on bind at this beautiful site, CPP reference. You'll find lots of information on it. But we need to actually understand how these two actually differ and what is the effect of the calling convention on this. And I mean the calling convention of this guy. Does it have an impact on what's happening when we do the binding if we're passing something specific? So we're going to look at that, and that will be the next piece of the installment. What I can do now, though, is actually take a look. I think we've looked at all of those. Here is the code exactly that we've looked at, right? Here is my compare. So that's what I promised. That's a bind, compare. One is passed through, and then the other value is hard-coded. And that's all I really need to do, right? Remember that the two values will be A and B. So A will be the pass-through. B is the one that I hard-code. And the implementation of my function is exactly as before. It's up here, no changes, except, of course, for what I don't like, right? This should really be a T, but you get the idea. If I actually go and compile that, so that's clo number 4, I can pick up clo 4, send that in clo, compile, run, and I get exactly what I was expecting. This is working exactly as it should. I have now made use of that specific function to get through. That's all there is to it. Now we need to really understand the idiosyncrasies of these passing parameters and how they affect us when we're binding things that are supposed to be by reference. What's the story? As you can imagine, binding things that are by value are not going to be all that difficult to deal with. See you next time.